Good afternoon, everyone. This is Walter Surik. I'm the CEO of Savant. I'm just going to briefly talk about the threat landscape. I'm sure most of you live this every day, so I'm just going to go through this quickly. On the threat landscape, we look at it three different ways, or three different sources: cyber crime, cyber espionage, and cyber sabotage. On the crime side, it's basically people trying to steal money or get money directly from you. One thing that is on the rise is ransomware. Ransomware is a type of malware that will hijack your machine and displays a ransom message like the one you see here. Often it appears to be from a law enforcement agency, the IRS, your bank, some other trusted source. And they claim that unless you pay the ransom, your machine and your data is going to be locked up forever. There's one that you may have heard of called CryptoLocker, which is hitting in the UK. It's also hit here in the US, where they're demanding a 2 Bitcoin ransom to receive decryption of your code, to actually decode your data. These attacks are on the rise, and what's particularly troubling is that they're hitting smaller companies and also manufacturing companies. And I'll just give you a quick real-world example. Here we're in the Boston area. A local police department just got hit by this, and they actually paid the $750 ransom. But even closer to home, two of our customers that we're actually working with, both are in the process of deploying Savant. One in particular was attacked via a phishing email notice of a fax waiting for the accounting manager on the fax server. She clicked on it and ended up wiping out her machine and wiping out all of the accounting data for a manufacturing company. And another example, a manufacturer who had recently had an industrial accident. They received pictures of the accident from law enforcement on a USB stick. When the person responsible for that division put the USB stick into his machine, basically locked up his machine, locked up their entire manufacturing database, and they're still struggling to fix this. The only good news that we saw from all this is that they were in the process of installing Savant, and any machine that had whitelisting on it stopped it. That's probably the only positive news as they're still dealing with this. On the cyber espionage front, there's been a lot of news around this. Basically, it's the stealing of designs, your IP, and really the attacks from nation states are the ones that are really on the rise. There was one recently, last year, called Gauss. It was highly complex, nation state sponsored cyber espionage toolkit, basically designed to steal data, browser passwords, online banking credentials, and interesting enough, configurations of machines. Now, initially people thought it was just towards the banking sector or towards the Middle East itself, but recently Kaspersky has said that it has a USB module with spy functionality that's 128-bit encrypted payload. And they still haven't been able, a year later, to decrypt it, but they believe it's targeting ICS air-gapped machines. Also, interestingly, Kyle Lilholt of Trend Micro, some of you may know, he actually created a ICS honeypot to lure potential hackers into what would appear to them to be a small town water treatment plant, town of about 18,000 residents. Mainly, he did this to see who was attacking ICS and what they wanted. Aside from sabotaging the system, he salted some documents to actually track where the hackers came from, but they did steal much of the plans and designs and other financial information of this fictitious water treatment plant. And lastly, on cyber sabotage, again, another area that's increasing, where hackers are leaving persistent backdoors. Now, in the past, they would typically just wipe your data, but I think they discovered a lot of people had backing up their data, at least daily, even hourly. So what they've done is they've gotten even smarter, and what's more worrisome is that the trend is towards slowly corrupting your database. Now, you don't even know what's happening. That's what's really worrisome about it, is that you get wiped out, you can go back, people keep their backups for a good amount of time, but if you're being slowly corrupted, you may have no chance of recovering your data. The biggest example of this was Adobe, which is a big company you would think was highly secure. They had their customer data stolen, it was partially deleted, and then their source code to their product was actually compromised. Another point I want to make is no entity is too large, too small. You see data from Symantec, and this was for 2012, basically saying that the attacks doubled against organizations that had 2,500 employees or more, but it tripled against organizations with less than 250 employees. And interestingly, 31% of all the attacks that they recorded were against companies that were less than 250 employees. On the ICS landscape, there's not a lot of data. Trend Micro has provided some. And you can see that there were about 200 confirmed incidents, at least in the first half of 2030, according to Trend. Now, what's interesting is that we know this is way underreported, mainly because of the stock market and regulatory impact of companies actually admitting to having their systems breached. But we know what's happening. And lastly, I'm just going to go over one of the big attacks. We haven't seen, as some people in the ICS space say, we haven't seen an ICS Armageddon yet. And that's true. We almost did, though. Saudi Aramco had a major cyber attack in August of 2012. Basically, it was the Shamoon virus. It affected 30,000 of their computers. It wiped their hard drives completely clean, posted a picture of burning American flag, as you can see there. It basically forced them to shut down their corporate network for 2 weeks to stop it and to try to recover. There's been some debate, in terms of what they're really telling us and where it came from. That's likely triggered by either a USB stick by an insider or a spear phishing attack against one or more of their staff. So basically on the threat landscape, the bottom line is that the number and the sophistication of attacks from outside and inside your organization are going to continue to grow as we move forward.
And now I'd like to introduce Pete Jenny with Security Innovation, who's going to cover some additional territory. Pete?
Hello, how are you? We skip up to the next slide. Industrial control systems are very vulnerable. We'll spend a little bit of time talking about just how vulnerable and why. But in general, there's a lot of pushback in the industrial control space against normal security measures. People in the ICS network space generally tend to see the security as an obstacle that gets in the way of the process. The process is the gold standard in ICS, and everything that has to do with everything that has to do with the network has to do with keeping the process going, whether it's the distilling of petroleum, the making of whatever chemical they're making, and so on and so forth. We can see that the priorities versus IT versus ICS networks are rather different. In IT implementation, we're worried about confidentiality, integrity, and availability. And in ICS networks, we're worried about availability first, making sure the process is going. Integrity is second, and confidentiality is third. That kind of gives you an indication of why they think security is a burden. Next slide, Amy. So the way that ICS networks are supposed to be set up are completely separate from other networks. They should be air-gapped from the IT network. In other words, there only should be one path from the ICS network out to the enterprise network. And we can see from this diagram that a proper setup would be to have the industrial control systems, the SCADA master systems, and so on and so forth, being completely air-gapped, completely separate from the corporate network, only maintaining unidirectional communications. In other words, from the ICS network out into the IT network, not the other way around. The IT networks are the places where the biggest threats reside, and you want to keep those away from the ICS network. Next slide, Amy. So it's very difficult to defend against any kind of attacks. Symantec comes out and says there's little or no defense against zero-day attacks. An attack against any system can do all kinds of very, very bad things. They're just antivirus in general just doesn't cut it because it's a post facto device, and you have to keep updating the systems. One thing that you want to make sure that ICS systems are not connected to the internet, that they shouldn't require constant updates for blacklists and whatnot. So they make it very difficult to maintain. Other attacks can do all kinds of other things. As a matter of fact, after the fact, they can hide themselves. They can destroy any kind of forensic evidence that you have. They can just leave you in really rotten shape, and you need to protect against that in all cases. Next ring. So I don't know if Walt gave you enough fear, uncertainty, and doubt in this whole thing, but Leon Panetta came out and told us that we're in really deep trouble, and we're just waiting for the biggest thing to happen. There have been no really major attacks. There have been no deaths or anything like that in any kind of ICS attack, but all it's going to take is one, and there's a lot of people out there that are doing some pretty nasty stuff. So everybody needs to keep their eyes open as far as defense of our industrial control systems and our critical infrastructure. Next screen. So whitelisting is actually a really good mechanism for securing industrial control systems. The primary thing that whitelisting provides is process control. Nothing that is not supposed to run can run. So any kind of virus, any kind of junk that somebody tries to dump on your machine just can't execute. It's the basic first strike mechanism. It keeps your systems completely safe, and it doesn't require any kind of updating per se. So once you set up your process controller or your SCADA system or your distributed control system and whitelisted the applications that you want to run, nothing else can run. It's very highly recommended. It augments other security systems. If you really feel like it, you can run a blacklisting system on top of it as long as you don't try to update it through an internet pipe and things like that. But it really does do the job. Next slide, Amy. So there are some basic ICS requirements in general. First off is that the system has to run in isolation. As I've said a couple of times already, you can't have a connection through the internet to the outside world. You can't have something that's bidirectional that goes out and picks up HMACs or hash codes or anything like that. You can't have something that goes out and picks up blacklists. You have to make sure that you're protected against propagation. Propagation is a virus starting on one machine and jumping to another machine and just running rampant through your network. You have to make sure that your communications are outbound only. They won't accept any kind of incoming connections. During the installation, particularly in the case of legacy systems, you have to make sure that there's no rebooting, and there's no process breakage, and there's no manual reconfiguration necessary. And also, to go on top of that, it has to be really fast. I was at a facility a while back, and I was talking to a fellow about reconfiguring his network and making sure that it was secure, and then putting stuff on top of it to keep it safe. And he asked me how long it was going to take. And I said, well, probably a couple of weeks, and we can have you locked down and going. And the fellow looked me right in the eye and said, dude, we've got a 4-hour per year maintenance window on this system, so you can do whatever you can in 4 hours. And so I kind of had to backpedal on that one. But that's pretty typical of the ICS space. They have maintenance windows, and you have to get in there and do things quickly. So you have to do something that's at a very, very high value, very, very quickly. So also, you have to support existing systems. ICS networks and process managers and things like that are responsible for regulatory reporting. They are responsible. They already have their own systems all configured, and you can't change the way they work. And you have to watch out for the kind of operating systems they use. They've got all kinds of old stuff. They're very resistant to change. And ICS networks are the only place that I still see NT4, Windows 2000, and XP up to SP1, and nothing much beyond there. They just tend to stay with the old stuff because all the new stuff with the highly secured breaks all of it, so they don't want to use it. Systems have to be transparent. In other words, they cannot have any effect on the running software. They, of course, have to be bulletproof and not allow anything that's not supposed to happen. And they have to be stable and standalone. That speaks again to the runs in isolation and the local whitelisting. It needs to worry about availability before confidentiality. So the process is king. It's the golden process that has to keep on running. And anything you do to affect the process is bad. So availability has to be paramount. And you have to be able to support multiple vendor operating systems. As I said, you need all the Windows. You probably you'll need Linux. You need when you get down into the device level, you need other things like QNX or RTOS or something like that. Next slide, Randy. So where do you start? The whole industrial control space is enormous. I mean, this diagram here kind of describes the way things look. From the network side, you have the perimeter, the network, and then control stations in the middle. On the ICS side, you have sensors, controllers, and whatnot, all the way back into control stations. If you wanted to try to lock down all the sensors, it would take you forever. There are thousands and thousands and thousands of sensors and PLCs and with programmable logic controllers, other devices that make up the sensor space and the controller space. And there's just too many to fit. So the place that you really want to focus is on the SCADA system. So they're basically control stations that monitor and manage all of the devices that make up the process. So that's the place to focus. That's the place you want to put your whitelists. And once you've done that, you protect everything that's downstream from the control stations. Okay, Randy, I think we're done.
Great, Pete. Thank you very much for that.
No problem. Thank you.
So at this point, I want to talk a little bit about the logistics of deploying application whitelisting into an ICS environment. And our view is that it's a four-step process. Initially, to discover what all of the executables are that run on the endpoint. Secondly, to establish what will be trusted in terms of applications and executables that are allowed to run on the endpoint, as well as if there are any sources of automated trusted change that should be defined. Next is to go ahead and secure the endpoints by locking them down. And lastly, to provide logging capability so that you have a trail of who did what, who changed what, whether it was authorized, what was blocked, what wasn't authorized, and so on. So in the discovery phase, you should be able to create a scan of the system to identify every individual executable that's on the machine, so that you know what's running on that endpoint. Is it in policy? Unnecessary? Should it be removed before going to the next step? An example of the kind of output that should result from that exercise is here in what we call system intelligence, where we can gather all of the high-level applications and then drill down to the individual executables, and then to be able to make a decision about whether they are critical to system operation, should be culled out, etc. The second step is the establishment of trust, of course, the creation of initial whitelist on that endpoint of all that will be authorized. And you may find in some environments that there are remote monitoring and management systems that may be used within the OT network to update or patch the application, etc. And so it would be at that point to establish the automated trusting of that particular provisioning system. And so here you see an example of what we call a filter step. And in this example, I've used the Alturas deployment server, which might be used to provision machines to the operating environment, and that it would be the source of operating system updates or application updates, etc. Next in the process would be to secure the machines, and that would be moving them into what's called lockdown mode, which would create the deny by default posture. If it's not on the list, it won't run if you're in. And so there's a couple of different flavors of this. A machine deployed into the factory environment would be in lockdown mode, meaning that executables cannot be written to disk regardless of their source. The endpoint, whether it's attended or unattended, cannot add, modify, or delete any software. And as you see here, all of the privileges of that machine would be denied. So that's a hardened machine, unable to support any changes whatsoever. And if the user does attempt to, that information should be logged, kind of copy, add, modify, or delete. Lastly, a robust ICS protection system should also include some external storage device control capability, so that in addition to preventing executables from running, you also have the ability to prevent any new data files from coming onto or leaving that machine, depending on what the requirements are. There's, of course, going to be a time when you have to administer that endpoint, and so the whitelisting solution should have the ability to locally administer that machine by switching user, putting back on with an entirely different set of privileges, to then be able to make all of the changes locally, or they can be made remotely, or they can be made from a central management console, and that varies from one deployment to another. But in any event, any changes that are made should be logged, stored locally, as well as stored remote. And the system design should be such that even when in administrative mode, the protection is never interrupted. You don't want to have a maintenance window that leaves that device exposed while you're administering. And then lastly, a good robust ICS solution should have extensive logging capability, and those logs should be able to be delivered to wherever the customer's environment might dictate. And so being able to specify exactly which events you would like to log, and having the ability to send them to a variety of different places in addition to keeping them locally. As organizations become more sophisticated and devices like security information event management systems, syslog, and other types of third-party logging systems are put in place in the OT environment, the solution should be able to accommodate whatever the customer's architecture is. So a quick, at this point, a quick ad for and why we think we are uniquely suited for this kind of an environment. We have a patented and very innovative client-centric architecture, which creates a unique local whitelist on each endpoint that we protect. Only the executable list will run, and it's important to note that in our implementation, we're not only focused on the high-level application, but on every underlying executable, every .exe, .sys, .dll, etc. And so on a typical XP machine, we would be protecting somewhere between 15 and 25,000 different executables. On a Windows 7 machine, it's typically between 20 and 50,000 executables. The fact that in our particular design, we do not require a central whitelist, that eliminates the need for incoming and or outgoing communication to the endpoint. So our solution can operate indefinitally in a fully disconnected environment because it doesn't need to check with anyone else to decide what's good and what's bad because it has its own local list. Another element of our proprietary patented design is that we use unique keys for each executable on each endpoint. And so the same DLL running on two different machines in the Savant environment will have a unique hash on each of those computers. And the advantage to that is that if you look at how something like Stuxnet spread, it spread from one machine to another over networks or via USB sticks, and our approach using these unique keys will prevent the propagation of malware from one Savant protected machine to another. And we support not only an extensive set of legacy platforms going all the way back to Windows 2000, multiple versions of Windows Server. We also have the ability to deploy Savant into an existing operating environment, or we can be deployed into a net new environment as part of an image. So when we are deployed as part of the operating environment, we don't require any reboot of the machine. The install occurs silently in the background, and so you're able to maintain the operation of the asset while putting the protection in place. And it looks like I got ahead of myself a little bit on that slide. I already talked about a couple of these things. And once again, tremendous amount of logging information available. Not that you need it because we will have stopped anything that's not on the list, but inevitably you'll want to go back at some point and look at, well, what tried to execute, or who actually installed what and when. And so you have that extensive trail of information available for your use. So simplistic representation of what we do. Savant starts up at the very lowest levels in the operating system at the mini kernel filter driver level, which is the approved way of doing things within the Microsoft operating system environment. And so each executable that is presented to the CPU is compared to see if there is a valid encrypted key stored for that executable. If so, it's allowed to run, and if not, it is denied. And so I want to, at this point, just give you a brief demonstration of the product functionality, and then we'll go and look at the questions that have come in from the chat window. So bear with me for just a moment. I'm going to log into a remote server where we've got a demo set up. All right, so in this particular server, we are configured what we call this an operator workstation, which is to say it could be headless. There may be a monitor, keyboard, and mouse. There may not be. But in any event, this machine is configured with Savant so that it is in, as you can see here as I pull up the user interface, it's in lockdown mode, which means you can't bring anything new on the machine, you can't delete anything, you can't modify anything. And you see here that these other functionalities are grayed out, and in fact, if this particular operator went to look at things, he would find out that everything is grayed out with one exception, which is the switch user function, which would be how an IT or an OT admin would come to that machine and then be able to administer it. So I'm going to show you here, if I go into the executable list within the machine, and I'll just pick on Adobe for a moment, if a piece of malware or an operator unintentionally or intentionally tried to delete any component on the system, it will be blocked by Savant from being deleted. And this messaging comes from Windows. Savant is configured to be totally silent in this environment, so an attempt to delete the file is going to produce this message, and although it goes one step further, you see that although it wanted to confirm yes or no, when you say yes, Microsoft comes back and says, no, you're not allowed to do that. Would you like to try it again? And it doesn't matter how many attempts you make to delete that file, they will be blocked. The same is true if we attempt to, if something attempts to rename something, which is a common behavior in malware exploits. Again, you see that I can't modify anything on this machine. The next kind of thing that can occur in this environment might be that if this ICS device did have network connectivity, we like to think that they generally don't. If I had network connectivity and I ran off and went to a website like Adobe and I tried to download something from it, let's see here, bear with me just one moment. So if I try to save what I'm downloading, again, you see that it failed. So I can't bring anything new onto the machine over the internet. Let's just close this out. The next example of a way something might attempt to get on the machine would be from a USB stick. And so on this USB stick, I've got two things. I've showed up for the overnight shift at the power plant, and I've put iTunes on my USB stick, and I'm pretty sure I can plug that into the workstation. And so I try to bring this on to the machine, and Savant will block it. I could try to run it from that USB stick, and in this case, Microsoft, in addition to Savant, is silent, and so it looks like it's going to run, but again, it is not allowed to run. The other example I want to show you is if a piece of unknown malware happens to be on that USB stick, or is a part of an attachment on an email, or is part of an infected link that goes to a website that's got the potential to deliver a drive-by download. Again, that unknown piece of malware, when it attempts to execute, will be blocked by Savant, and if it tries to jump from the USB stick or from the email attachment, etc., and come onto the machine, Savant, being in lockdown mode, is going to block that attempt to execute and or to come onto the machine. So those are the key attack paths that are typically seen. And what I want to lastly show you from a demo standpoint is, get to the right one. If, as the IT administrator, I now need to come to this device locally or remotely, we've got a full user interface that will allow the IT admin to switch user and now have access to the complete set of functionality available from that local user interface, which would allow the IT admin to install a new application, to update an application, to authorize or unauthorize individual executables on the machine, and take advantage of the broad set of administrative capability that Savant puts in place. And of course, there's many midpoints, if you will, from a fully locked down machine with no privileges to one that, as we've just shown here, offers the complete set of IT admin capability. There could be various different levels in the middle. In other words, you might say, well, the supervisor is allowed to install software, but not allowed to authorize or unauthorized executables, etc. Not sure where that kind of situation might develop, but we have the flexibility to support it if that were to occur. So that concludes the demonstration part, and so I'm going to now go take a look at some of the questions that we've gotten and do my best to answer them. So let's see, first question, are we saying that we can't develop a standard whitelist image for like clients? And the answer is no, not at all. We can create on our management console a standard image that would be put down on each individual endpoint, and that standard image would could optionally have all of the same keys assigned to each of the executables, or at the time of deployment, we can still take advantage of that proprietary capability that we have and regenerate keys on each endpoint. So you could put down a uniform image with a set of keys that match for every one of your ICS, HMIs, historians, workstations, etc. Or at the time when that machine comes up, Savant can create a new and unique set of keys for each computer, which would give you that added security protection against the kind of propagation that Stuxnet and other malware like that tend to try to take advantage of. Okay, so the next question has to do with which Microsoft operating systems are supported. And so we support back to Windows 2000, XP, Vista, Windows 7. Windows 8 will be available shortly, although I don't see a lot of ICS folks deploying Windows 8 just yet. We also support Server 2000, 2003, and 2008. Okay, let's see. That appears to be the only two questions that we have so far. And if anyone would like to, I know many of you have been very kind and have muted yourselves as you're listening here today, but if you'd like to unmute at this point, we'd be happy to entertain any audio questions in addition to the few that we've gotten here via chat. All right, well, I would suggest that we've done a very thorough job and we've given everyone the information that they were hoping to get out of today's session, or that several folks are taking a nap. I don't know which one it is, but that's just my silly sense of humor. So if you do have any questions going forward or would like more information, would like to have a free trial, my contact information is available here on the screen now. And for those of you who have attended, I'm going to put together a PDF version of the slides and send that off to you. And hopefully you've found this to be a useful session. And please, give us your feedback. And we hope that we're in a position to help you address these very difficult and challenging security problems that we all face in the ICS environment. So to wrap things up, Pete, Jenny, thanks very much for joining. Walter, thank you for helping. And we'll bring it to a close for today. Thanks, everyone. Have a great day.